Today, let's revisit them and clear up 10 common myths about black holes. 1. Black holes suck everything like a vacuum cleaner. This is probably the most common mistake. People imagine black holes as cosmic monsters pulling in everything nearby, but in truth, black holes follow the same laws of gravity as everything else. If we replace the sun with a black hole of the same mass, the Earth and other planets would continue orbiting exactly as before. We'd lose sunlight, yes, but the orbits wouldn't change at all. The only difference is density. A black hole with the mass of the sun would be only about 3 kilometers wide instead of 1.4 million kilometers like the sun. The gravity is the same, it's just concentrated in a tiny region. 2. You need a giant star to make a black hole. Mostly yes, but not always. In theory, any mass can become a black hole if it's compressed tightly enough. To form one naturally, a star needs to be at least about 20 times heavier than the sun. When such a massive star runs out of fuel, it explodes as a supernova, and its core collapses into a black hole. But theoretically, even the Earth could become a black hole if you could shrink it down to a 1 millimeter sphere. It's just that nature doesn't have a mechanism to compress matter that much. 3. All black holes are infinitely dense. Not exactly. Black holes are dense, yes, but infinite density is just a sign that our equations break down. For example, a supermassive black hole 1 billion times heavier than the sun would have a radius of about 3 billion kilometers, roughly the size of our solar system. Its average density would actually be lower than water. Of course, near the center, density skyrockets. But talking about infinity doesn't make physical sense. It just means we don't yet have a full theory that combines gravity and quantum mechanics. 4. Black holes are literal holes in space. Despite the name, a black hole isn't a hole you can fall through like a pit in the ground. It's a region where space and time are curved so extremely that nothing can escape once it crosses the event horizon, the point of no return. If you fell into a black hole, you wouldn't feel a sudden pull or fall through a tunnel. Crossing the event horizon would feel completely normal, but from that point on, every possible future leads toward the center. You can't turn back. As you approach the core, tidal forces stretch your body like spaghetti, a process called spaghettification, until even your atoms are torn apart. 5. There's a point of infinite density at the center. Physicists call it a singularity, but it's not a real physical point. It's where our current understanding of physics breaks down. General relativity predicts infinite curvature, while quantum physics says that's impossible. Somewhere in between lies the true answer, a theory of quantum gravity, which we haven't yet discovered. Whatever exists at the heart of a black hole remains one of the greatest mysteries in science. 6. Black holes are portals or gateways. This one's popular in sci-fi. Some believe black holes connect to other universes through wormholes or white holes. It's an interesting idea, but so far there's no observational evidence for it. The mathematics allows for the possibility, but physics doesn't yet support the reality. For now, a black hole is simply a one-way trip. 7. Black holes are completely black. Not quite. It's true that no light escapes from inside, but Stephen Hawking showed that black holes actually emit a faint glow, now known as Hawking radiation. According to quantum theory, tiny pairs of particles constantly pop in and out of existence near the event horizon. One particle falls in, the other escapes, stealing a bit of energy from the black hole. That means black holes can emit radiation, just very, very faintly, mostly in the form of radio or gamma rays depending on their size. 8. Black holes last forever. No, they don't. Because of Hawking radiation, black holes slowly lose mass over unimaginable timescales. The bigger the black hole, the slower it evaporates. A supermassive black hole might take trillions of years to vanish, but given enough time, even the largest ones will eventually disappear, leaving behind a cold, empty universe. 9. Black holes don't move. They do. Black holes are physical objects with mass, so they move, spin, and even collide. When galaxies merge, their central black holes can spiral together and eventually merge too, producing enormous gravitational waves we can detect here on Earth. Some collisions can even fling black holes out of galaxies entirely. Astronomers have already found about 20 rogue black holes drifting through intergalactic space. 10. Black holes are invisible. You can't see the black hole itself, but you can see its surroundings. Gas and dust spiral toward black holes, forming accretion disks that heat up to millions of degrees and shine brighter than entire galaxies. That's what we saw in the first ever image of a black hole. Not the hole itself, but the glowing ring of gas around it. It's almost poetic. The brightest thing in the universe forming around the darkest.